Hey guys, Corey here. Welcome to my crash course on Apollo GraphQL Server. This video is made with Apollo GraphQL Server version 2. However, this video in particular is targeted more towards people that are new to GraphQL Server and just want to know a little bit more about how it works, how to set up, and to go through a sample implementation. However, if you are curious about some of the new version 2 features, I will be doing a separate video on that. However, trying to encapsulate beginner Apollo server information and v2 enhancements would just create a much longer video that I could really fit in one session. So for this video in particular, we're going to start out by going over what Apollo GraphQL Server is, how it works, and then we'll just do a brief overview of what's new in version 2, and then we'll go over an example implementation done in Node.js. Node.js is the primary implementation. If you go around and search for different, for documentation references, most of the examples are going to be in Node. Occasionally you'll see like a PHP or Go language example, but Node is pretty much the go-to standard for Apollo GraphQL implementations, at least for the server. Okay, so first off, what is Apollo GraphQL Server? I've made a little visual here to help us understand exactly what it is. GraphQL Server is an endpoint that sits in between all of our clients and all of our different backend services that we typically operate with. This is huge for a few different reasons. The first one is it reduces the complexity on the client, and it does so dramatically. Previously, if you were using REST endpoints and third-party APIs, each client would have to call those endpoints and operate on them individually. If you use an Apollo GraphQL Server endpoint, you can really encapsulate all that complexity under that single endpoint, which is really great, especially when you're dealing with multiple different client devices. Apollo, on each front-end device, you have the thing called Apollo Client that hooks up to whatever operating system you're working with. This video is not going to go over Apollo Client. We're only touching the server in this video. Behind the scenes, it does connect with other services such as your primary database, an ad server if you're serving ads to your customers, other microservices that you may use, and whatever cache server you're using. You can really do all this under the Apollo GraphQL Server endpoint. Another advantage of this is you only need one endpoint, whereas a lot of the Express implementations, they would typically use several endpoints for different operations that you need, such as they have one endpoint for employee, they'd have another endpoint for employer and location, and it really got really complex as you add more and more endpoints. With GraphQL, you only need one, which is great. It also reduces bandwidth. So with GraphQL, basically what you're doing is you're serving a query. You're telling this one endpoint exactly what you want, the exact properties that you want, and then the Apollo server will only return those properties. Whereas your typical REST endpoints would just return one huge payload, and you're essentially discarding whatever you don't need. So given that the reduced payload, the bandwidth hit is much lower with Apollo GraphQL. Another good thing about Apollo GraphQL Server is it supports advanced features such as subscriptions and pagination. And this is one thing that Apollo really separates itself from the other GraphQL Server offerings out there. Subscriptions and paginations are advanced features, and luckily Apollo GraphQL Server supports those operations. So how does it work? So with Apollo GraphQL, you have three main operations that you can do. You have a query, which just reads and returns data. You have a mutation, which alters and it will optionally return data. And then you have another operation called a subscription. A subscription updates the client with new data based on some sort of triggering event. So one use case would be, you think about some sort of sports app that clients need to get updated on a score. If you're using a subscription, whenever that score would be updated, it would send an update to all the clients that are currently subscribed to whatever game you're watching. And it'll just update the score on the clients. This video is not going to cover subscription because that is an advanced topic. I'll have to cover that in a separate video. Now, if we get a little bit more granular, Apollo Server has three main structural components. And this is essentially how we're going to build our Apollo Server implementation. Typically, you'll have a thing called type defs. And what type defs is this is more or less just your schema definition of your data. It's basically, you can consider it like a table of contents of essentially how your data is structured. So in this example, I just listed here, you have a query, and I've listed here 4 basic queries that I could essentially operate on. Name of the business, and you have your type here, so string. Location is a string, number of employees is an integer. And then I have this other field here called employee, and it's got this data type that you don't recognize as standard. This is more or less, this is a custom type, and I've called it employee uppercase. And whenever you do that, you'll have to define the custom type, and that's what I've done right here. So I've defined a custom type called employee, which contains an ID of type int, a name of type string, and a picture of type string. You'll see more how this works in our actual demo, but this is a way that you can really reduce the complexity in your schema structure. You'll also have a mutation definition and a subscription definition as well. For a mutation example, I mean, really simple. You can put whatever definitions you want under mutations in terms of how you can actually update your data. In this case, I just have an add employee example. It takes in one parameter, a name of type string, and it returns the type of employee. So more or less, this type defs is just a definition of your schema. The next one, and it's really the heart and soul of GraphQL, are the resolvers. The resolver is a function that can do almost anything. So here's an example. I just have one example here of this name of business. Essentially, you're defining exactly how you're going to retrieve this name of business. So for example, in this function, you can go out and connect to a database, you can retrieve information, and then you can return that data back to the client. You can do the same thing with your custom types that you've done. You can do your own resolver functions if you want to do something very, very granular. One good thing about the types is you actually do have access to your parent entity. So typically you have a parameter called parent value, and that contains data from the parent instance using whatever parent instance is using the type. So in this case, this employee type, whatever properties were used for this employee property, you'll have access to with this employee type, which is pretty cool. Same thing with mutations. It's more or less the same. It's essentially executing a function that can connect to some sort of data store, optionally alter the data, and then optionally return data back to the client. The third structural component is middleware, which we're not actually going to do in this video, but you can do things such as database connections, logging, and authentication. Anytime you want to do these operations, you typically want to use some sort of middleware component. So some new enhancements in version 2 that were either not available in version 1 but enhanced. And I'm just going to briefly go over each one of these. The first two, automatic persistent queries and CDN integration. Both of these tools are used to essentially cache data on the server. A lot of the V1 implementations would use a custom Redis database as a cache. However, it appears that Apollo Server essentially offers a cache out of the box, which can be pretty cool, and it can prevent you from doing a custom Redis implementation, which is pretty neat. They also have support for GraphQL errors, in which you can create your own custom errors that developers can see when they're trying to query your server. You have schema mocking, which essentially allows you to more or less mock out your data, and you can run through tests and stuff. You have performance monitoring, which is a way that you can just see where bottlenecks are on your GraphQL server. There's GraphQL Playground, which I actually will be going over. This is a replacement to your V1 graphical solution. It allows you to just query data and mutate data and do subscriptions without actually hooking up to an official client, which is really helpful for testing. There's also support for file uploads. You could actually do this in V1, but it was pretty complicated. And now there's support right out of the box. Same thing with subscriptions. There's improved support for subscriptions. And there's also health checks. Okay, so the example implementation I'm going to go through is a really simple server where you have an employee and employers. And each employer will have multiple employees, and one or more employees, I should say. And each employee will have an employer. And so there's a lot of different things that we can do with this. We can query an individual employee. We'll be able to query an individual employer and look at data under each one of these. We can also query all employers and all employees, which will essentially just return an array of the list of employers or employees. We'll have two custom data types, employee and employer. Each one of these will have, the employee will have an ID, name, and it'll have a referential key called employer ID, which references the ID of the employer. And the employer will have, obviously, the ID. It'll have a name. It'll have the number of employees that it has, which this is going to be a custom function, which is a pretty cool thing in GraphQL that I'll show you. And it'll also have the employees, so you can look at all the employees that belong to a certain employer. From a mutation perspective, just 4 different queries, which are pretty simple. You have the ability to add an employee. You have the ability to remove an employee. You have the ability to change the employee name, and you have the ability to change the employer. All right. Okay, so that's a lot of talking. I'm going to go ahead and move into the actual code implementation of this crash course. Okay, the first thing what we're going to do is we're going to open up a command prompt, and we're going to make a new directory. We're just going to call it Apollo Server Example, and go ahead and cd into that directory. And we're just going to run npm init and --yes. And this is just going to create a blank node project, just bare bones. And that's all we really need for this example. And next, we're just going to install 2 dependencies. We're going to install Apollo Server and GraphQL. So I'll do npm install --save Apollo Server and GraphQL. Apollo Server, this is the Apollo Server library, and it allows us to really focus on defining the shape of our data and essentially define how to fetch it. The GraphQL library, that's just a library to essentially build the schema and execute queries on the schema. All right, so now that that is done, what we're going to do is we're actually going to open that up in our code editor. I'm using Visual Studio Code, but you can use whatever code editor you would like. Okay, so I'm going to find Apollo Server example. I'm going to go ahead and open this guy up. Now we've got a blank project here. So I'm going to go ahead and create a new file. And you'll do this for almost any Node project. You'll create an index.js file. And this is more or less a blank file. I have my Vim editor set up. I'm just going to go ahead and disable that. Just because it can be a little confusing doing a demo with this. All right, okay, much better. All right, so starting out, there's a few things that we want to do. First off, we're going ahead to import some of the libraries that we had just installed. So I'm going to do, actually, since we're on Node, I'm going to do a const Apollo server, and we're also going to import GQL, and we're going to set that equal to require Apollo-server. Okay, we're not going to use these libraries quite yet. The first thing that we're going to do is we're actually just going to define some fake data. Now, normally, you would want to use some sort of actual data store, but for this example, we're just going to use it's just some fake data, or I guess I should say fake static data. So I'm just going to define some employees here. Let's see, I'm going to create ID 1. I'm going to name a guy. I'm just going to call him John Smith. And I'm going to give him an employer ID, which I have not defined yet, of 1. And I'm going to take this guy, and I'm just going to replicate him a few times. And I'm just going to come in here, and I'm just going to change some of this information here. I'll just create a fake name, Lauren Armstrong. We're going to have her have the same employer. Let's see, our third employee, we'll make him Henry. I'll just call him Henry Bautista. He'll work for the same employer. The fourth employee, however, we'll give him a different employer. I'll just call him Jake. I'll just say Jake Snarl and give him an employer of 2. Now I'll define our employer array. This is more or less the same thing. Let's see, we're going to give it an ID of 1. And we're just going to give it a name, and this is going to be its only property. I'll just call it Harry's Pub. And let's see, I'll just duplicate this guy. And for the second one, I'll just say UPS, the shipping company. I think that'll be simple enough. Okay, so now that we have our fake data set up, it's time to do the first part of our GraphQL implementation. If I just go back to my little example here, I'm going to start out by just building the type defs of our implementation. And again, this is just the schema definition of our data. So it's more or less just a map of how we would actually use it. So the way you do that is you just define a variable called type defs. And we're going to wrap our GQL tag I know this looks a little confusing at the moment, but this is ES6 syntax of how you can essentially pass in a string to a function. So we're going to wrap this GraphQL tag around this string. And first off, we're going to create our query type, and this is just going to house the queries that we're going to use in our project. We're going to do 4 in total. We're going to do employers, which is just going to return all of our employers that we have. We're also going to do employees, which is going to return more or less all of our employees that we have defined. Then we're going to create 2 queries that are a little bit more granular. They're actually going to take in a parameter of an ID, and it's going to return a single employer. And it's essentially going to return whatever employer this ID matches. Next, we're going to do an employee, and it's more or less going to be the same thing, but instead we're going to return a single employee. All right, so now as you can see here, we have some custom types that we've created, this employer and employee. In this top situation, you see that I have this wrapped around brackets, and this essentially lets GraphQL know that this is actually going to return an array. But regardless, we're going to have to actually define these different types here. And we're going to do that right here below. We're going to do the employer type first. And for this guy, I'm going to define a few different properties. It's going to have an ID, of course, and it's going to be of type int. Next, I'm going to have a name. That's going to be a type string. I'm also going to do an employees, and this is actually going to have an employee data type with brackets, which is essentially an array of employees. And I'm going to do another object right here called num employees, and it's going to have a type int. And this guy will actually, it's actually a function that's going to be executed, and you'll see that here in a second. I guess you could call it like a computed variable, but you'll understand more about that in a little bit. Next, we got to define our employee type. So we'll call employee, and it's going to take in an ID of type int. It's going to use a name of type string, and employer of type employer. So one interesting thing that I'll point out is that this employer type and employee type, they actually reference each other. So this employees references the employee data type, and this employee data type references employer. So technically these guys could nest each other infinitely, but we're not really worried about that. That's really up to the discretion of the developer who's querying this. So next we're going to define our mutation types. So we're going to have 4 mutations. We're going to do add employee, and it's going to take in a name of type string, and I'm going to put in an exclamation point after that string. The exclamation point just tells GraphQL that this parameter is required. If you try to call add employee and you did not include the name, it will throw an error and it will not allow you to continue. I'm also going to do an employer ID. It's going to take a type of int, and I'm also going to put in an exclamation point to indicate that that is required. And it's going to return a type of employee. This return type is optional, but I'm just going to use it for this example because I first, as a developer, if I call add employee, I'd like to just see that employee return just so I can feel confident that the update actually did go through. All right, I'm going to do another one called remove employee, and it's going to take in a parameter of ID with a required int, and I'm just going to return the employee list just so I can see all the employees except for the removed employee. I'm going to do another one called change employee name, and that's going to take in a required parameter of ID of type int, and I'm also going to do a name of type string, and it's going to be required as well, and it's going to return an employee. I'm also going to do employer. Essentially, this function is going to allow the user to change his or her employer. It's going to take in an ID. It's going to take in an employer ID of type string. And it's just going to return an employee. Okay, so that's it for our type defs. So next up is really the meat of the project, and that's the resolvers. Before I actually do the resolvers, I'm just going to go ahead and do this other piece of the project, which is a little bit simpler. I'm going to call a const. I'm going to call this variable server. I'm going to set this equal to new Apollo server. And Apollo server, this is essentially what we're bringing in here from the package that we downloaded via npm Apollo server. And this is essentially going to take in two variables. It's going to take in the type defs that we just created. And it's also going to take in our resolvers that we are about to create. Second off, we're going to do a server.listen. And this is actually going to take in a promise of URL. It's going to have a parameter of URL that we're going to define. And this is just going to have a callback here. And I'm just going to do a console.log. I'll just say server is ready at, and then whatever URL is brought back to that parameter. This is essentially just listening on a port, and it's just going to tell us how to access our GraphQL playground. Okay, so now that that is done, we're going to move on to the resolvers, which is probably the most complex piece of this setup. And so when we're creating this resolvers, we can reference our type defs here, because it's really just, it's the type defs again. This is our map of our schema. And so for each one of these, we'll essentially call each one of these to execute some sort of resolver function. So I'm going to start here doing query. And we're going to start off by doing the employer query. And this is actually going to take in two arguments. So with this thing, I think first I'll actually explain how the arguments are actually structured. Typically, what you'll have is you'll have a parent value as the first parameter. You'll have args as your second parameter. You'll have context as your third parameter, and info as your fourth parameter. Now, the parent value, this is typically referenced not necessarily at your root query. This is more used on some of your type definitions that you created. Parent value is essentially a reference to whatever parent definition called it. So in this example here, when we actually go down to create the employer type definition, employer type definition, whenever we execute one of these functions like num employees, we can actually reference the parent's properties with the parent value parameter. Args is used if this function in particular is passing any sort of arguments into it from the client. So like when we get down to add employee, see how we have some parameters that are passed in. You can essentially access that using args. Context, this is typically something that you would use during your setup process. if you are to use any sort of authentication information or database connections or any other data like that, you can essentially pass that to context. Info, that's just essentially some sort of data payload that you want to customize and pass in. For our implementation, we're not going to use these, we're not going to use these last two parameters, info and context. So I'm just going to remove them. This employee query here, we're not going to use parent value because it is at the root query, so it's useless. So I'm just going to denote that by an underscore. We are going to use args though, at least for the employer query. Okay, so I'm going to pass this an arrow function. And what I'm going to do here is I'm going to actually call the employer's fake data that we built up here. And I'm actually going to add an S on there. I'm going to call it employers. And I'm essentially going to loop through this guy. I'm going to run a filter function on it. And I'm just going to do a check. I'm going to call it E. And I'm going to create another arrow function. And it's essentially going to loop through each employer. And it's going to check the ID of the employer. And it's going to see if that is equal to our args.id. Now remember, so this args.id, this args references whatever arguments that we're passing in. And if we look here up at our employer function that we made, we are passing in an ID. So if we want to use that ID in our resolver function, we'll define the args parameter and we'll reference that in our resolver function. So this employers.filter, this actually returns an array, but we just want to get a single element out of here because we are just returning a single employer. So I'm just going to add in a 0 under brackets there, and that just returns the first argument on the array. In this case, this array is just going to have a single argument, so that should be sufficient here. Next, I'm going to do this employee function, and it's going to operate almost the exact same as employer. So what I'm going to do, just to save some time, is I'm just going to copy this guy down, and I'm just going to change this to employees, employee, and more or less this is just going to operate the exact same. It's just going to return a single employee based on the ID that we pass in through args. Now the next thing that we'll do is we're going to do a simple query here called employees plural. Actually, let's do employers first. And this is just going to take in a function as well. I'm not going to use any arguments for this guy because employees, there are no arguments taken, so we don't really need to pass in anything here. This is going to define an arrow function though, and we're just going to return employers. And essentially this is just referencing the array up here. It's literally just going to return whatever value this is. Okay, and we'll do the same thing for our employees query. Just the same. Okay, so next up, we're going to do the employer type. And this is a little bit more involved than some of the ones that we just did. So this employer, what you can do is you can define custom functions, custom resolver functions under this employee data type. And these are optional. You don't have to do these. But if you do, and your client requests that parameter, GraphQL will execute this resolver function. And I'll show you right here. So you remember this num employees? I think I told you this is actually a computed property. So what we're going to do here is we're actually going to define a num employees resolver function. And this is going to take in parent value, if I can spell it right, parent value parameter. And this is actually going to execute a function here. So parent value, if you remember correctly, this is essentially going to reference whatever parent value called employer. So in this case, it should be both the employer's query here and also the one that takes in a parameter, the singular employer. And this parent value will essentially take in the properties that were defined during each one of these function calls. So just to help us see it, I'm just going to console.log parent value in employer. And whenever we run this, we can actually see that parent value in action. All right. Okay. So now we actually need to compute the value. So what we're going to do is we're going to return employees.filter, and we're essentially going to loop through the employees array, and we're going to check to see how many employees have an employer ID of this employer. So we're going to define E, which is just going to reference each employee in the list, and that's going to take in its own arrow function, and we're going to check employee.employer ID, and we're going to check if that is equal to our parent value.id. And this list is going to, essentially this filter function is going to return all the items, all the employees that match our parent value employer ID. And so for this, we're just going to want to look at the length of this array. And that will essentially tell us the number of employees that are under this employer. All right, so I'm going to do another custom function here called employees. And this is also going to take in a parent value. And this one is going to be almost pretty much the same thing as this guy, but I'm just not doing dot length. So I'm just going to copy and paste this guy here. Okay, I'll put a trailing comma on that. And now what I'll do is I'll actually define the employee resolver functions. And this one's going to be pretty simple. I'm just going to do one employer sub function. I like to call these sub functions just because it just makes sense. Let's see, parent value. For this guy, I'm just going to return basically whatever employer that this employee belongs to. So the way I'll do this is I'll just call the employers array, and I'll filter through. I'll define an E parameter which references each employer, and I'll look at the ID of that guy, and I'll test to see if it equals the employee ID. Sorry, the employer ID of our employee, which is we're able to get that through our parent value. Since this is an array and I just want to get one value here, I will also just denote the bracket 0, which just returns the first item on the array. Okay, great. So that should be done. Next, what I'll do is I'll go ahead and build our mutation. We've got 4 of them here. I'm going to do them one at a time. The first thing I'm going to do is add employee. And this is not going to have a parent value because it is on the root mutation. But it is going to have arguments. And that's obviously these right here. So we should expect these to be passed into arguments. We're going to define an arrow function. And what we're going to do here is we're going to create a new variable called new employee. And this is essentially going to be our arguments that were passed in with the addition of an ID we're going to define this actually in GraphQL. We're not going to have the user pass this in. The reason being is because we want this to be unique. I'm going to kind of cheat here. I'm just going to do employees.length plus 1. In a production instance, you'd want to use a library that helps you dynamically generate an ID, such as UUID. But for simplicity's sake, I'm just going to look at employees.length, and I'm just going to add 1 to it. I'm also going to define the name as args.name. And I'm going to do employer ID as args.employer ID. All right, now that that new employee variable is created, I'm going to actually take our employees array. I'm just going to do a push onto it. I'm going to add this new employee onto the array. Okay, excellent. The next thing I'm going to want to do is I'm actually going to want to return the new employee. Because if you remember, whenever we define this add employee, we are defining a return type of employee. So I need to make sure I pass in an object that replicates the values that I find here. Okay, that looks good. All right, so next up, what we're going to do is we're going to add in our remove employee resolver function. And this is same sort of structure here. It's not going to have a parent value. It's going to take in an argument. It's going to do an arrow function. And we're going to return employees.filter. And we're essentially going to loop through the list. And whenever we find our employee ID that we want to remove, we're just going to omit it from this list. And we do that with filter. So we're going to do e.id. And you're only going to return the element if it does not equal args.id. And this is just going to allow us to loop through the list. Whatever ID equals the ID that we've passed into arguments, it's going to skip over it. And this will return the list that does not include the ID that we passed in. So that one was simple enough. Next one is change employee name. And it's essentially going to have the same argument structure, underscore args. And what we're going to do here is we're going to define a new employee variable. I'm going to assign it to let because we will change the property later on down. So the first thing I want to do is I'm going to want to change the employees array. And after that, I'm actually going to return the changed employee. So I've come into here. I'm actually going to set, I'm going to set employees equal to employees.map. Map is just a way to alter your array. And I'm going to set it back equal to employees. If you remember way up here, I did assign this as a let, so you are able to edit this. Okay, so where are we? Okay, so employees equals employee.map. This is just going to take in a single argument. I'm going to call it E, just so it's more concise. And this is going to call a function, and I'm just going to check the employee's ID. Actually, I'm just going to do an if statement here. If employee ID equals args.id, which is what we passed in, we're gonna actually just take reference to this. We're gonna say new employee equals. We're gonna spread out the employee's properties, and by using a deconstruct operator, and we're just gonna override the name with whatever name we passed in to our argument. And then after that, what we're going to do is we're going to, let's see, return that changed employee. Actually, no, I take that back. If this if statement does not, well, let's see here. Okay, so after this new employee is set, we're actually going to return the new employee. And this essentially updates this array with this entry. And it'll take the new name. Okay, so if this condition does not match, what we're going to want to do is we're not going to want to change anything. And we're just going to say return E. This makes no alteration and just continues on looping through all the employees. Okay, so after we loop through all employees and we change the name that we want to change, what we're going to want to do is we're going to want to return whatever employee that we changed. If you remember up here on our schema definition, we have this changed employee name. We do return an employee object off of there. So we are going to make sure that we return that employee object. So I made reference of this earlier with this new employee equals, its existing properties plus the name. So I'm just going to do a return new employee. Excellent. Okay, so change employee is done. The next thing that we're going to do is we're going to do change employer. And this is literally the same thing as change employee name. The only thing that is different is that instead of name here, it's just going to be the employer ID. So what I'll do is I'll just take this information and I'll just copy it down. And all I'll do is I'll change this from name to employer ID. And I'll actually just change this to employer ID. All right, excellent. So now that that is done, what we're going to want to do is we're actually going to want to execute this. And then we're going to go into GraphQL Playground and just make sure that all this works. Okay, so I'll open up the terminal. Let's see here. Okay. I'm just going to use Visual Studio Code's built-in terminal. Okay, what I'm going to do is I'm going to just run node index.js. Oh, let's see. Okay, type defs is not defined. I thought it defined that. Const type defs. Oh, okay. I just misspelled it down here. Okay, type defs. All right, save that. Let me try this again. Okay. Server is ready at HTTP localhost 4000. So what I'm going to do is I'm just going to copy this and let me, where is it? I'm going to look for GraphQL Playground. I think I have it here. Let me just, what I'll do is I'll just put that in there. Okay, excellent. What I'm going to do here is I'm just going to go through some of the queries that we did. Employee. And we're going to do a name and ID. Okay, so a few notes about this language here. This GraphQL language syntax, it's really not too difficult. You essentially, if by default, if you don't specify query, mutation, and subscription, it assumes you're doing a query. Typically, you would define it up here, like query, and then whatever the name of the query is, and then you can do some operations down here. If you don't do anything here, it just assumes you're doing a query. And you do whatever query you want to do. And if you look back at if you remember back in our code, let's see, where are you? Oh, that's not it. Where are you? Okay. If you look back in our code, if you remember back to our type defs, these are all the queries you can do. Employers, employees, employer, employee. So if we go back to our playground, we can do just employee. It takes no parameters. And we can just do some of the IDs that we defined. So let's see. We're doing, let's do employees, plural. And what we'll do here is this takes back an employee or an array of employee. And so what we'll do is we'll go down here to the employee type and look at some of the properties that you have here. So they've got, name and employer. So first let's just do ID and name. And we'll run that. And here we go. Here's our list of employees. We've got John Smith, Lauren Armstrong, Henry Bautista, Jake Snarl. So that looks great. What we can do here is we can do one of our I call it sub functions, employer. Now this employer, see how it gives me this red line under here? This is complaining because this does require subfields. So we actually have to branch this guy out, and we'll just do like ID, and we'll do name here too. The reason why it complains is because if you think about it, if we go back to our type defs, under employee, when we actually call employer, the employer calls a type called employer, uppercase E. And it won't allow you to just return this. You have to actually come down here and open it up and define parameters that you want under here. So if we go back and try to run this, there we go. Now it's got all the employees, but now each employee lists their employer. So you see John Smith works for Harry's Pub, Lauren Armstrong works for Harry's Pub as well, and so does Henry Bautista. It's only Jake Snarl that works for UPS. So we can also do this for, let's go ahead and change this. We'll change this. We'll do employers. And I'll just do ID and name just to show you that this works. So just list out the employers here, Harry's Pub and UPS. So a few other cool things that we can do is we can do this num employees. You heard me talking about this computed function here. If we run this, let's see, it doesn't like whatever we did here. Console is not a function. It seems like a silly error. So let me come down here. Oh, yep. That's really dumb. Console.log. Employer, newbie mistake. Unfortunately, I have to rerun this. Okay. So let me just, let's try this again. Employee is not defined. Let's see here. It should be down in our num employees. Oh, yep. Okay. Okay. Sorry about that. This should be, instead of employee, this actually should be e.employer_id. And same thing here. This should be e.employer_id. My mistake. So let me try to run this again. Oh, sorry. I got to rerun the node index.js. Let me try this again. Okay, much better. Okay, so now what you can see happened here is that we requested num employees. And so what happened is back in our in our resolver definition, what happened here is since we requested num employees, this function executed. If we did not request num employees in this query, if we did not request this here, this function would not execute. So if you think about this, this is very powerful. This allows you can do some really shallow queries and just return data that you need. But for some of the client interactions that need more complex data, you can create little sub functions like this to execute, computed functions or more complex analysis that you need for some of your data types. Okay, so that's great. So I'll just create the num. I'll just do that again. Num employees. I will also do, I think, employees, which this is turning red because what it wants me to do is it wants me to define some properties here. I'll just do ID and name. And again, that is because here in our type defs, when we do type, when we're using the type employer and we call this employees, it expects back an array of employee types. And so with that, you have to define some of the parameters here. So if we run that, here's our array of employers. Harry's Pub, it's got 3 employees. And then here's our list of employees. Same thing with UPS, it's got 1 employee and a list of the employees here. Now what's kind of interesting is you can continue to loop this if you really wanted to. You could do employer, ID, well I'll just do name. And then you can do employees, and this could have an employer, and this could have employees, and you could just loop on and on and on and on if you wanted to, based on our schema design. And it would just literally just go on forever and ever and ever. But that's just one of the powerful things of GraphQL. It allows you to do really highly complex things like this. Okay, so next up, what I want to do is I'm actually going to do our singular functions here, our employer and employee. So let's see if I go back to our playground. What you can do here is you can define, let's see here, query employee. When you take in parameters, you're going to want to go ahead and explicitly define query up above. And what you're going to do is you're going to pass in $ID or whatever your variable name is, and you're going to define its type. And this needs to match whatever you're doing in your query. So whatever this is, you need to make sure it matches. So that should be good. Okay. Whoop. Sorry. I don't know what. Okay. There we go. And under this, you're going to want to do employee as well. And this is just you're going to define your ID, and it's going to take in the ID that we defined up above here. And this, at this point, we can just name whatever data we want to get back. We're just going to do ID and name. And then we got to do something interesting, which is a query variable. Query variables is essentially what your client will pass in, and whatever you define here gets passed in up here. So in this case, I'm just going to define an ID, and I'm just going to do an ID of 1, just for an example here. And this is a JSON, so you can't have leading commas. All right, so if I execute this, what it's going to do is it's going to pass in ID 1 up through here, and then it's going to pass it down to our query in this $ID 1. So if I run this, boom, John Smith is our employee. And I can actually just do, if I wanted to, I can do employer as well, just to show you. You can see what his employer is, Harry's Pub. It looks good. So now let's do, let's try employer. I'll just change this a little bit. We'll look at the employer of ID1. It should be Harry's Pub. Yep, it is. And we can also do our other sub function here, and we can list out our employees if we want. Just do name. Yep, and that works just fine. You pass in the variable of 1. It gets passed into the employer query, which if you remember back in our schema definition, you're passing in an int you're passing in a parameter of ID of type int to the employer function, and it returns an employer type definition. All right, so that looks good. So the next thing that we're going to test is actually our mutations. So for mutations, what I'm going to do is I'm just going to remove this, and I'll just go to remove this too. And what I'll do, instead of query, you're going to define mutation. And what we'll do here is we'll do add employee. And if we remember add employee, let's go back to our type defs. Where is it? Add employee, this is our type definition here. This takes in 2 parameters, a required name of type string, and a required employee ID of type int. And then it returns the employee data type. So if I go back to my playground, I'm going to want to define a $name of type string. I think I have to do int there. And then I'm going to do employer ID, and it needs to be a $. And this is going to be of type int, and it's going to be required. So now I'm going to execute add employee, and this is going to take in a name, and we're going to assign it to the variable that we had assigned up above, and it's also going to take an employee ID of the variable that we defined above, employee ID. And now you're going to define whatever you want in the return. If you recall, it's a return type employee. And a quick note about this, obviously you can do ID, name, and employer. You don't have to request all of these. You can just do one or all of them or a subset. It's whatever you want. What I'm going to do is I'm just going to do, what the heck, I'll do ID, I'll do name, and I'll just do employer name. I'll just go and do all of these at first. And then we can't forget that we have to actually go down here to query variables. We're going to have to actually define these. So, I don't know, I'll just do like Michael Johnson. And I'll do an employer. We'll just say that Harry's hired him. I'll give him an ID of 1. And we'll go ahead and execute this. And okay, well, there's our add employee, and looks like that went through successfully. What I'll do is I'll just go and add a few more. I'll just make a few people up. We'll say that Kara Fletchall was hired by Harry's as well. Let's give UPS a new employee. I don't know. I'll say Tony Jefferson. I'll give him an employee ID of 2. All right. Now what the heck? We'll do one more. Carrie. I'll just call him Carrie Lindsay. And we'll say that Harry's hired him. All right, so that should be added. So what I'll do, I'll just cut that because I kind of want to go back to it later. I'll just do another query, and I'll literally just do, what I'll do is I'll just do employees, ID, name, employer, name. We'll see if this worked. All right, so if we look at our new list, you see we've got some new employees that we added. Great. So that query works. Now what we'll do is I'll just reverse this. We'll go ahead and test out our remove employee. Remove employee. This is only going to take in one parameter, and that's going to be of type int. Oh, sorry. It's going to be $ID of type int. Let's see. Variable ID is never used in remove employee. Oh, sorry. No, it's complaining about this down here. Remove employee. And I'll do ID of type ID. I'll delete all this. Let's see here. Okay, it's also, if you remember correctly, remove employee. What this does is this this returns a list of employees. So if we come back here, we just, whatever items we want from our list, we're just going to define here. And I'll just do ID and name. That's it. We got to remember to define our query variables. So I'll make sure to do an ID. Shoot, let me just remove, I'll remove this Kara Lindsay. She's the last person added, so, okay. All right, okay, so it returned the remaining list of employees, and as you can see here, ID number 8 is gone. So it looks like that works. So the next thing that we're going to do, if we go back to our typedefs definition, we have this change employee name that we have to test. We have change employer that we have to test. So let's do change employee name first. Takes in two IDs, or two parameters, ID and name, and returns type employee. So we'll come back in here and just define this. Change employee name. And what was it? Is ID? Yeah, I'll keep the ID there. And we'll actually do name. Sorry, $name of type string. And let me change this to change employee name and ID. Assign that to our $ID that we defined above, and same thing with name. Define that with $name that we defined up above. All right. Our return type is the employee. So I'll just do ID and name just so I can make sure that that name is changed. I think what I'll do here is I'll change the 6. I'll change Kara Fletchall to a different name. We'll pretend that Kara got married and we need to change her name. So it's going to be ID 6. And we're going to change that to Kara Davis. We'll pretend that Kara married a guy with the last name of Davis. All right, so this should be good. Okay, sorry, we got an error. I think I need to put an exclamation point there. Yeah, okay, sorry, I forgot the exclamation point on string. But now it looks like, sorry, it looks like this was not changed. One second, I think maybe I made a mistake in my resolvers. Let's see, change employee name. So this goes through here, and let's see, if eid equals args.id, it's going to assign new employee to this, return new employee, and then down here I'm actually doing new employee. Here, let me go back. That looks right. Let me go back and let me just look at employees. I'll just look at them all. ID and name. Okay, so Kara did not change. So something's going on here. Okay, well, it seems like I made a really stupid mistake. I named, when I copied this resolver function, I forgot to rename this guy. It should be change employer. So that's what was really screwing me up, is it was essentially, all it was doing was just changing this employer ID. So I've changed that. So if I go back here to the terminal, unfortunately, I'm going to have to restart my node instance, which is actually going to take away the employees that I created. But it shouldn't take me but a second to add those back in. So let's see. Let me go back far enough. All right, so add employee. Okay. So I'll come back here, and what I'll do is I'll just add those employees back in really quick. Let's see. No, I want to do Michael Johnson. Let's see, Michael Johnson. And employer ID of 1. So let me just add these guys back in. So Kara. Richard Jefferson. Let's say he works for UPS. That should be good enough. All right, so if I go back, what I'll do is I'll just do employees and ID, name, employer, name. All right, we got him back. So what I'll try to do now is I'll just try to I'll try this again. I'll try to change Kara's name from Kara Fletchall to Kara Davis. All right, so up here at the top, I'll do mutation. And this is going to be, actually that's lowercase, mutation. And this is going to be change employee name. And I'll do $name, or sorry, $ID, type int, and $name, type string, both are required. And I'll do change employee name, ID. We're going to send that to the ID we just defined. Same thing with name. And this is going to return, if I remember correctly, it's going to return an employee data type. So we're just going to look at the ID and the name. All right. Query variables. You go on, do an ID of, let's see, Kara's ID is 6. And change this to Kara Davis. And I'm going to take out this employer ID here. All right, what is this complaining about? Oh yeah, comma there. No comma here. All right, try it again. There we go, Kara Davis. Whew, okay, I'm glad that worked. Now the last thing that we're going to change is the employer ID. So we'll say that Kara is got a new job and she's going to go work for UPS. So we're going to want to change that name. So we'll do change employer. And we're going to change this from name to employer ID. It's going to be type int. It's going to be employer ID. Same thing with this guy, employer ID. And change this to employer. All right, and what I'll do is I'll just do employer, employer here, and do a name, and what the heck, I'll do ID too. All right, and down here we got to change our query variable, employer ID, and we're going to change it to 2 because that's what UPS's ID is. And we'll go ahead and run that. And let's see. Variable employer ID of type int, used in position expecting type string. Ah, crap. All right, I made a small mistake here in my schema definition. This needs to be an ID, this employer ID. Because if you remember up here in our fake data, we are defining an integer. So I'm going to take a shortcut here. And what I'll do is I'll save this. Since I changed that back to ID, I'll just save this. And what I'm going to do is I'm just going to rerun this. And I'm just going to copy this guy. I'm just going to list out the employees. Again, name, ID, name, and employer. We're just going to change the employer of one of these guys. We'll say that John Smith got a new job at UPS. And so what I'll do is I'll just paste this back. All that should be good to go. Let's see, what is this complaining about? It's expecting a type string. The only reason it says that is because I just haven't refreshed the browser. I'll just go ahead and do that. What the heck? Okay, so now it's not complaining anymore. Okay, that should be good. So let me go ahead and run that. See, change employer null. That means it didn't work. Let's see here. All right, I made a stupid mistake. I forgot to reset the ID. ID needs to be 1 because that's what John Smith's ID is. It's not 6. All right, there we go. Awesome. Now John Smith has been changed to UPS now. He works for UPS. So if we come down here, let's just go ahead and just look at all the employees. I'll just do ID, name, employer. Sorry. All right, so now you see John Smith now works for UPS. Lauren Armstrong still works for Harry's. Henry Bautista still works for Harry's. And now Jake Snarl works for UPS. So now we can know that that thing worked. I'm happy that it worked. And now we're good to go. So I hope you enjoyed this video. I know it was long, but there is a lot to Apollo GraphQL Server. Be on the lookout for some videos of some of the advanced features that V2 offers. And maybe I'll just do some other ancillary videos on GraphQL 2, perhaps something on the client as well. If you would like to, please like and subscribe. And also, if you want just to reference the code that I did here, check out the link in the description. It's a link to the GitHub page where all the finished code is. All right, thanks. Have a good day.